The release of two remarkable new images of the interstellar comet known as 3I/Atlas has given scientists and the public alike an unprecedented glimpse into one of the rarest visitors ever observed in our solar system. One image was captured from Earth using the Gemini North Telescope in Hawaii, while the other was taken from deep space by NASA's Europa Clipper spacecraft as it journeys toward Jupiter. Together, these images represent a milestone in astronomical observation, combining ground-based precision with a unique spaceborne perspective to document an object that originated far beyond the gravitational influence of our Sun. The discovery and study of 3I/Atlas have not only expanded scientific understanding of interstellar objects, but have also reignited curiosity about the broader cosmic environment from which such bodies emerge. Comet 3I/Atlas first captured global attention in 2025 when astronomers confirmed that it was not native to our solar system. Instead, its trajectory and velocity indicated that it formed around a distant star before being ejected into interstellar space, wandering for potentially billions of years before briefly passing through our cosmic neighborhood. This realization placed 3I/Atlas among an extremely exclusive class of objects. It is only the third confirmed interstellar visitor ever detected, following the discovery of Oumuamua in 2017 and 2I/Borisov in 2019. Unlike asteroids or comets that form from the same primordial disk as the planets, interstellar objects are time capsules from entirely different stellar systems, offering invaluable clues about how planetary systems form and evolve elsewhere in the galaxy. What makes 3I/Atlas particularly fascinating is the possibility that it may be the oldest comet ever observed by humanity. Scientists estimate that it could be billions of years older than most comets found within the solar system, having formed during an early epoch of star formation in the Milky Way. Over immense stretches of time, it likely endured radiation, gravitational encounters, and extreme cold as it drifted through the void between stars. When it finally encountered our Sun, the increase in temperature caused volatile materials within its icy core to vaporize, forming the glowing coma and tail that define it as a comet. This transformation allowed astronomers to study its composition in detail, revealing chemical signatures that may differ significantly from those of native solar system comets. The first of the newly released images was taken on November 26, 2025, using the Gemini Multi-Object Spectrograph on the Gemini North Telescope, which sits atop Mauna Kea, a dormant volcano rising high above the Pacific Ocean. This location provides some of the clearest and darkest skies on Earth, making it ideal for deep space observations. Capturing 3I/Atlas, however, was no simple task. Comets move rapidly across the sky relative to distant background stars, especially when they are passing through the inner solar system. To compensate for this motion, the telescope had to track the comet precisely during long exposures. As a result, stars in the raw images appeared as streaks rather than points of light. Astronomers later processed the data to correct for this effect, producing a final image in which the stars appear fixed and the comet stands out clearly, its diffuse coma glowing faintly against the cosmic backdrop. The second image offers an even more extraordinary perspective. It was captured by NASA's Europa Clipper spacecraft, which launched in October 2024 and is currently en route to Jupiter. Although Europa Clipper's primary mission is to study Europa, one of Jupiter's largest moons and a key candidate in the search for extraterrestrial life, its instruments are already fully operational. As the spacecraft travels through interplanetary space, it has the ability to observe a variety of celestial targets. When scientists realized that Europa Clipper would have a clear view of 3I/Atlas, they seized the opportunity to direct the spacecraft's camera toward the passing comet. From its vantage point far from Earth, Europa Clipper observed 3I/Atlas for approximately 7 hours, from a distance of around 164 million kilometers. This prolonged observation allowed scientists to collect data across multiple wavelengths of ultraviolet light. By combining these wavelengths, researchers produced a striking image that reveals the structure of the comet's coma in vivid detail. In the composite image, gases emitted by the comet glow in shades of blue and green, while dust particles appear red. This color coding is not merely aesthetic. It reflects differences in the physical and chemical properties of the materials surrounding the comet's nucleus. Such data help scientists understand how interstellar comets interact with solar radiation and how their compositions compare to those of comets formed closer to home. The discovery of 3I/Atlas on July 1, 2025, quickly made it one of the most significant space science stories of the year. Within days, observatories around the world were racing to collect data before the comet moved too far away or became too faint to study effectively. Because interstellar objects follow hyperbolic trajectories, they pass through the solar system only once, never to return. This fleeting nature makes each observation precious. Every spectrum, image, and measurement contributes to a growing, but still very limited dataset on objects from beyond our stellar neighborhood. As scientists studied 3I/Atlas more closely, they noticed several unusual features that fueled both scientific debate and public imagination. Observations from the Atacama Large Millimeter Array revealed that the comet deviated slightly from its predicted path by about 4 arcseconds. Additionally, its color appeared to change dramatically over time, shifting from a reddish hue to a deep blue. Such anomalies can often be explained by natural processes, such as uneven outgassing from the comet's surface or changes in its rotation. However, the combination of these features led to speculation about more exotic possibilities. In a blog post that attracted widespread attention, Harvard astrophysicist Avi Loeb suggested that the observed anomalies might even hint at a technological origin, such as the presence of an internal engine. While he emphasized that this was only a speculative idea, the suggestion was enough to spark intense discussion across scientific and media circles. Many researchers urged caution, noting that extraordinary claims require extraordinary evidence and that natural explanations were far more likely. Comets are complex and dynamic objects, and small forces caused by jets of gas can significantly alter their trajectories and appearance. In response to the speculation, astronomers undertook targeted efforts to search for signs of artificial technology associated with 3I/Atlas. On December 18, 2025, just one day before the comet reached its closest approach to Earth, scientists used the Green Bank Telescope in West Virginia to scan the object for technosignatures. These would include radio signals or other emissions that might indicate the presence of extraterrestrial technology. Despite the sensitivity of the world's largest fully steerable radio telescope, the search yielded no evidence of anything unusual. The absence of detectable technosignatures reinforced the prevailing view that 3I/Atlas is a natural object, albeit an extraordinary one. Although the idea of an alien origin has not been supported by evidence, the scientific value of 3I/Atlas remains immense. As a visitor from another star system, it provides a rare opportunity to study material that formed under different conditions than those present in the early solar system. By comparing its composition to that of native comets, scientists can test models of planetary formation and gain insights into the diversity of processes that shape planetary systems across the galaxy. Each interstellar object discovered so far has surprised researchers in different ways, suggesting that there is still much to learn about these cosmic wanderers. As 3I/Atlas continues on its journey, it will eventually fade from view, slipping back into interstellar space and carrying its secrets with it. The images captured by Gemini North and Europa Clipper will remain as lasting records of its brief visit, preserving details that may be studied for years to come. For astronomers, the comet serves as both a scientific treasure and a reminder of how vast and dynamic the universe truly is. For the public, it is a powerful symbol of cosmic connection, a fragment of another star system that crossed unimaginable distances to momentarily share our sky. In the end, 3I/Atlas underscores a humbling truth. Our solar system is not isolated, but part of a much larger, interconnected galaxy filled with wandering relics from distant suns.